So, hello everyone. Now we do the queries. We'll start with the queries given by the professor. And you can see that, again, one trick with the queries is, well, not really a trick, but something that's extremely convenient is the return type of the query is already provided. If you go here, see here, well, if you have implemented this interface in your My repository, yeah, you can see the return type integer, double, list, set. It's already provided, which makes things a lot easier. So overall, you'll notice that there's three types of return types that we are given. They ask us to return either a primitive type like int, double, string, etc., or it's like a or an implementation of the list interface. So list or set. Or one more thing that I've noticed is optional. So optional is something a lot of you probably don't know already. So optional will cover it as it comes, but let's start with list and set. So what is a set? The people who have done math already, you know that a set is something that does not have any repeated values, which also means sets can only be like sets can only have values that have equals and hash code, things that can be compared to each other for equality. So because set checks if two values are equal, because if two values are equal, then set won't have them in it. So yeah, when the let me see where they want set. Okay, here set get taken courses by limit and program. Actually, yeah, that is something I don't get. What is the limit? Does anybody know what the limit is? Let me see. Okay, in this case, I'm pretty sure if you ask the professor during the exam, what is the limit, he will tell you. So I will just explain the basic problem solving steps that you take. So yeah, you know what the sets are for, right? No repeated values. So optional is an interesting term. Let me see. Let me show you a query that asks for optional. Okay. So an optional can have a null value. An optional means that it can have a value or it cannot have a value. It's optional, as you know from the definition. So let me just use optional in the main function. Yeah. So optional is a generic class, which means optional needs a type. So think of optional as a box, and this box can have a value or it cannot have a value. It's chill either way. Like normally, if you don't have a value, you have to put in null, right? If you don't have an absence of a value is null. But in optional, it can not have a value without being null. So I'll just show an example real quick. Optional string. Then I need to import the class. Optional. This one. Anyway. Or my string. So this is an optional. And to start off, we can just make an empty optional. Have an empty optional. And we can check if this contains something. We just do if my string dot is empty, or I think is present means that there's nothing in there. So if it is present, we can do Or instead of that, we just print whatever is in that optional, what is in that box. So my, I guess instead of my string, it's chill if we do my optional. And in an optional, you can get the value, whatever is in the value by doing optional dot get. If it's not present, which means it's empty, then you just do nothing in the optional. What if my optional? So if you want to put something in the optional, you go optional dot off. Off is used to create a type like this. You might have noticed, like we haven't done factory classes and builders and stuff. But in sets, you will notice that you use off, for example, something that returns a set. Mm, set here. Well, I'll show you when it gets there. But off is used to create an optional, so you can do optional off. And optional of what? You just pass in a string. You can say Fahad. So this is the string. Now this box has a string in it, and which means that is present will be true. And in that case, we will print whatever is in it, and it prints Fahad. So the important thing about optional is that it could be anything. Optional can be a student, for example. It can be a student array, for example. It can be literally anything. It can be a student array, two-dimensional, three-dimensional, four-dimensional, five-dimensional, six. You get what I mean? It can be anything. It's just a box. So optionals is in some of the queries. There's set as well, but for that we'll just deal with it as we go through it. Now let's start dealing with the queries given in the country queries. Can you see this repository? Can you see this screen? I'll just confirm it right now. No, you cannot. Okay, now you can. Country repository. But this is for practice. Let's start with I'll just create a new class here, university, called theory practice. Okay, let's start with Firefox, Google Chrome. So the basic here is returns the value of the maximum population. So in students, instead of maximum population, I guess we can say the maximum GPA returns the value of the maximum GPA. So we can see that each student has, no, they don't have a GPA. Well, I guess year. Year is an integer. So we will just return the student with the biggest year. So it returns the value of the maximum population. So first, I'll just convert it to student real quick, and then I'll explain it to you step by step. Or I'll explain this first. So public long, if you don't know what long is a type of integer, like integer, but for even bigger numbers, like when you're dealing with huge numbers, if you paid attention in HLPL1, you know that integers has a limit. Yeah, I think it's like 8 bytes or something. But what if your number gets even bigger? In that case, you will need to use long. Yeah, you'll need to use long, which is, I guess, 16 bytes. It's bigger than an integer. So the return type is a long, get maximum population. So in the last video, I explained the very simple max algorithm for finding the biggest value in an array. So you do literally the same thing here. First, you create a list, countries, get all. What this does is, let me just, you know what, it's better if we just do everything here. Hmm. But public long get maximum tier. Okay, so what it does is it gets that list, get all from repository. It just gets every single entity. So in our case, the entity is student. So in order to get a list of all the students in the database, we do get all, and that's it. Get all will get all the students in the database. You can see here it returns a list T. We know T is student, so we can store it inside a list. We do list. What is the type? Student. Students is equal to get all. So we get all of the students in the database and we store it inside this list. Okay, so max, the max algorithm. So we have to go through every single student in the database and we have to see which student has the biggest year. And let me see what year even is because I forgot. Students. Hmm. The year of the student. Okay, so it's like a third year. Yeah, yeah, first year, second year, third year. Yeah. So we'll just get whoever has the biggest year. Okay, so in that case, the maximum, the biggest year, let's just set it to the first student to start with. You can see here. So we just go long max is equal to. Okay, so we have students here, right? The list of all the students. So students. So we get the first student in the list dot get because when you get something from a list, you use the dot get and index. So to get the first student would be at index 0. So students dot get the first student dot, like I said in the group, it's kind of like if you start thinking of it as a conveyor belt, there's four chefs in a line. The first chef prepares the dough and he passes it to the next chef who puts the tomato paste and then he passes it to the next chef who puts on the toppings and all that. It's basically that we take students, we dot get 0, which means we get the first student. Then students, every student has a year, right? So to get the year, we use the getter, get year, and that's it. So we take the first student, and then from that student, we take their year, and then we set the max, the biggest year to that student. But we're not done yet. Then we go through all the other students and check whichever student has a bigger value of year, they just get, they're the new max. So we just used, I guess, for loop for student, or a for I loop is more helpful here. So I starts at 1 because we've already done the first one. And while I is smaller than students dot length, well, students dot size. So when it comes to lists, you use size. You can see here as well, countries dot size. So students dot size. Now, starting from the second student, you check if max is the current max is smaller than students dot get at index I, which starts from the second student dot get here. If the year of this student, whoever we are looking at right now, is bigger than the current max, then the current max becomes this. A very simple max algorithm. And at the end, we just return max. So this is the simplest query we'll be doing. Does anybody have any questions about this one? Because you need to have this clear 100%. This is basically free marks. Okay, great. I'll assume that it's clear for everyone. We'll move on to the next one then. Returns the value of the average population. So, the formula of average is the total. Let me just confirm this max. Okay, it makes sense. Okay, return the value of the average population. So in students' case, instead of population, we can do hmm, because I really wish they had students had something like a grade, do year again. But year isn't really a number. Like, yeah, I could, but year is like it's like first year, second year, third year. It's not something you can add like grades. But sure, I'll just average up the years of each student. So this returns a double. Yeah, makes sense. Not a It's just an explanation. So we just return a double. Public double, get average year. So here you will learn a very important trick in the doubles. When you're dividing, right, at the final division here, one of the operands, normally the lower one, it needs to be casted to double. So the result is also a double. The signature is already given in the exam. Yes, that's the biggest benefit. The signatures are all given in here. See, double get average number of taken courses, for example. So get average year. It's a simple average algorithm. First, we set the sum. First, we will add up all the numbers in the list of students. So we'll just create the list again. This one, I'll just copy paste it, or I'll just type it. Why not? List of students is equal to get all. So we can do int number. Well, in this case, it's always safer to just do long number of students. How many students do we have in total? Students dot size. That's how many. Here they just do it directly with dot size, but this is an explanation, so I'll do it slowly. So we have this many students, and then we just go through each student and we add up their year. So long sum is equal to 0. Sum starts at 0. For students sum is equal to student dot get year. Well, not is equal to, it's plus is equal to. We just add it. And at the end, we can just do double average is equal to, so sum divided by the number of students. And number of students will be casted to double. So it goes like sum divided by number of students. And one of them need to be double. So we just cast this to double, like so. Boom. That's it. Get average here. Now, speaking of average, this last query had get I. What's the difference? Last query, you mean get maximum year? So the last query was maximum algorithm, which means we get the biggest value in an array. So get I means we go through each specific student, and if that student needs to, like, if we need to grab that specific student's value, we need to use I. That's why we use the for I loop. We were comparing the students. In this case, get average year. It doesn't matter. We don't really need to target any specific student. We just need to go through all the students real quick and just add their years. So add their years to the sum. Get I is used for like a specific, when each student is specific, like you need to get the maximum year here, students smaller than dot get I. I guess something a cheat code that you could use is, in this case, you need to start from the second student. So you use get I. In this case, we're starting from the first student all the way till the end. So we just use a for each loop. That's the simplest I can put it. So second to last, we use a for I loop. First to last, for each. So let's make things interesting. We have this get average number of taken courses. So it means per student, each student takes a number of courses, and we have to take the average of the taken courses. So for this, first we have to figure out taken. So taken courses per student. What's double? So as you can see, the return type is double. We have to return a double. And in this case, if you know how integers work in programming, for example, 5 divided by 2, in because they are integers, right? If you do like in this is going to store the value, it's not going to store 2.5, it's going to store 2. Yeah, F means like because I'm casting it. Why am I casting it? It's there because it needs to be casted. Like you see here, integer, right? If it's an integer value, integer div, 5 divided by 2, it's going to store only 2. It's not going to store the point value. So in order to make this, even if it's a double, all it's going to do is going to make it 2, and then it's going to make it a double later. So it will be 2.0. It's not going to be 2.5. If you want to make it like that, we need to cast one of these operands to double. This is used to cast. You've probably done it in C in HLPL1. We could have done this as well. It's the exact same thing. Yeah, it's just casting. One of them need to be casted to double, which means the result will automatically be a double. But yeah, get average number of taken courses. So each student has courses, right? Let me see the average. What is the equivalent here? By the way, with this, I'm pretty sure we can just ask the professor, like, okay, return average courses taken by the student, like by each student, or all the students in total. So let me just see, get average number of taken courses. I think what this means is we take the sum of, hmm, Yeah, we take the sum of taken courses by everyone and we just divide it by the total number of students. Yeah. So if the first student takes like three, yeah, exactly. So if the first student takes like three, first student takes like three courses, second student takes like four, third takes like two, the fourth, fifth, right, lost track, but like this. And we just divide it by how many? One, two, three, four, five. Divided by five, and we'll get the average courses taken per student. So it's actually pretty easy. So how do you get this courses taken by student? After you have a student, if you do get courses, you will get an array of courses, and arrays have lengths. So if you just do courses dot length, it will give you the amount of courses taken per student. So to start with, you do you always initialize the sum to zero. So long sum is equal to zero. You also get a list of the students. So list student is equal to get all. You store all of the students in that list. Okay, what do you do after that? You start going through the students. So you already have the total number of students. It actually helps to save it beforehand. So you can do number of students. And I do this because it just makes it easier to visualize it in your head in a mathematical way. So just do students dot size. Ricardo's asking, why does sum need to be long? Because what if they give a huge array? Like if they give an array that's super big and it overflows in the integer? Because let me see the maximum value of an int. An integer can only store a value as big as 214,748. This is the biggest value permitted by an integer. If you go over this, you overflow, and this value, if you go more than this, it will become this minus this. It becomes this. So if you want a bigger, because the integer is just, it's not big enough to store a value bigger than that. Hmm. Yeah, long has a capacity of, I think, double that of int. That's it. Long is a bigger container. So if the professor used long, it might be because he uses a huge ass container to test the queries. Just think of long as like two integers stacked on top of each other. It's like a Coca-Cola 1 liter versus 2 liter. Okay, so we just do long number of oh, I'm already doing it. Students dot size. Okay, so we go through each student, 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 in students, and for each student, we sum plus is equal to, because we are adding to the sum plus is equal to student dot we're doing taken courses, right? So okay, here's another hint. Get courses. We can see right here that it returns an array of course objects. Since it is an array, we find the length. So that adds to the courses taken. Okay. So, and at the end, we just return, or if it makes it easier for you, just to double, which would average is equal to sum divided by number of students. And you know the rule. Yeah, yeah, this is what I'm gonna call. Okay. And you know the rule. We have to convert one of them to double. Yeah, Wait, we just tell them not to spam. Of course, that is spamming. Bro isn't even in the meeting. Let me check if he's in the meeting. No, he's not. Okay, so we convert it to double. Can I run this? Sure. Let me try running it. Okay, so far we have written the get average number of taken courses and get average year and get maximum year. So we create a new my repository. We do my repository dot get average or get maximum year has been implemented. So first we print the maximum year, get average year as well, right? Yeah, get average year. And what's the third one we implemented? Get average number of taken courses. Which is return statement. Yeah, get average year as well. We just return the average that we calculated. Okay, so get the maximum year. Because computer science is only a 3-year degree, it makes sense that the maximum year, yeah, is to the biggest year is 3 because there's no fourth years. Well, except if you fail. But yeah, I guess in this sample test, they got rid of everybody who failed. Okay, so 1.8 is the what is get average year. So I guess if we take the average between 1 and 3, it should be somewhere like because there's a lot of second years. Yeah, it came up to like 1.8, but it's acceptable. Like that's how we know it's working. If there was an error, this would be like 26. Okay, the get average number of taken courses. 2.9. Yeah, because this guy took 2, this guy took 3, this guy took 3, 2, 3, 3. No, this one is 4, 2, 3. Yeah, so it checks out, right? It's nearly 3 average number of taken courses. So it's some of you guys are way better at math than I am. These theories, they check out, right? F, probably. Applied statistics got to you. Okay, so it checks out. The approximate should be near 2. It's 1.8. So yeah, it makes sense. Return the average, return the value of the average population, European countries. I guess we'll continue the queries from the next class, well, the next meeting, because there's 2 minutes left. Well, 1 minute, 50 seconds. So the next one, I'll start it as soon as the countdown ends, which is like 10 minutes. So see you guys in 10 minutes.